The humming sound produced by electrical appliances, such as transformers, motors, and electronic devices, is a result of various physical phenomena associated with their operation. The specific science behind the humming noise can vary depending on the type of device and the underlying mechanisms involved. Here are some common explanations for the humming sound in electrical appliances. 1. Magnetic fields and induction. Transformers. In electrical transformers, alternating current, AC, passes through coils of wire. The changing magnetic field induced by the alternating current can cause the transformer's metal core to vibrate, producing a humming sound. This phenomenon is known as magnetostriction. Inductors and coils. Inductors and coils in various electronic components can also produce humming sounds due to the interaction between the magnetic field generated by the flowing current and the physical structure of the device. 2. Mechanical vibrations. Motors and fans. Motors, fans, and other mechanical components in appliances can produce vibrations as they operate. These vibrations can generate sound waves in the surrounding air, resulting in a humming noise. The design, construction, and balance of these components can influence the intensity and frequency of the humming. Imbalance and resonance. An imbalance in rotating parts or resonance in the mechanical structure can contribute to the humming sound. When the frequency of the vibrations matches a natural frequency of the structure, resonance amplifies the sound. 3. Electromagnetic forces. Magnetic attraction and repulsion. In some devices, electromagnetic forces between components can cause vibrations and produce a humming noise. For example, in speakers, the interaction between the magnet and the coil can lead to vibrations and sound production. 4. Electronic components. Power electronics. Electronic components, especially those associated with power electronics, can generate humming sounds due to the flow of high-frequency currents. Inductors, capacitors, and other components may contribute to audible vibrations. Piezoelectric effect. Some electronic components, such as piezoelectric crystals, can vibrate when subjected to an electric field. This vibration can produce a humming noise, and devices containing piezoelectric components may exhibit this characteristic sound. 5. Airflow and turbulence. Cooling fans. Fans used for cooling purposes in electronic devices can produce humming sounds as they move air. Turbulence in the airflow or vibrations caused by the fan blades can contribute to the overall noise level. 6. Materials and damping. Material properties. The materials used in the construction of electrical appliances can influence the propagation of sound. Materials with different acoustic properties may absorb or amplify vibrations, affecting the perceived humming sound. Damping. Damping materials are used to reduce vibrations and noise. The effectiveness of damping in minimizing humming noise depends on the type of material and its placement within the device. Conclusion. The humming sound produced by electrical appliances is a complex interplay of electromagnetic, mechanical, and acoustic phenomena. Understanding the specific mechanisms involved in each type of device helps engineers design and optimize products to minimize unwanted noise. While the humming noise is generally a normal aspect of many electrical appliances, advancements in technology and design continue to focus on reducing such sounds to enhance user experience.